Hello, everyone. Welcome to this webinar co-hosted by the 6G Flagship project and the IEEE Sustainable ICT Initiative. I'm Jaafar Elmirghani from University of Leeds in the UK. And this webinar is co-organized by Tarik Taleb from University of Oulu and myself. So it is a pleasure to welcome you to the webinar and to welcome all the speakers. Without further delay, I'm going to start by just giving you an overview of the webinar itself and what to expect today. So I'll start by sharing my screen. Okay. And can I just check that my screen is visible?
Yes, it is.
Thank you. So as I mentioned, the event is sponsored by the 6G Flagship project and also the IEEE Sustainable ICT Initiative. It is free webinar available to everyone, and it is entitled Green Networking in Beyond 5G. And hopefully today we have the pleasure of welcoming a number of authorities in the field who are going to share their view with us. So we have had 278 registrants in this webinar from 55 countries, which is really very impressive, showing the great interest in the area, but also the great interest in the speakers and what they hopefully will share with us today. It's about 37% from industry, the people registering and have registered, and 63% from academia. Obviously, the webinar is going to be available after, so hopefully you will be able to watch it again, and those who have missed it but registered will be able to see it as well. So those are total numbers: 278 in total registered, 175 from academia, and 103 from industry. As I mentioned, it is from 55 different countries in the world. This is not every single country, but you can see quite a distribution from the US, Canada, around Europe, Japan, Far East, Middle East, and different parts of the world. So we're really very fortunate to see this, and it's a heavy tail as well. So there is quite a good interest here. Just some housekeeping remarks before we start. So before we begin, please, we recommend that you use your full name in the Zoom profile. It will make it easier to interact and hopefully answer the questions and so on. Please write your short questions in the Q&A window at any time, either with your full name or anonymously if you wish to. The dedicated Q&A will take place at the end of the webinar session. So at the beginning, we're just going to give an overview. We'll go into the individual talks, and each of them will be about 10 minutes. And then 15 minutes or so later, we will get into the discussion for maybe about half an hour or maybe a bit more. So this will be towards the end of the webinar. We will record the webinar, and it's actually being recorded now, including the Q&A session, and the video will be publicly available on different mediums. So welcome to the webinar, Green Networking in Beyond 5G, Challenges and Opportunities. It's sponsored by University of Oulu, where Tarik is, the Flagship 6G project, University of Leeds, where I am, the IEEE Sustainable ICT Initiative, the Engineering and Physical Sciences Research Council, and Mosaic Lab, where Tarik is the director. Here are our email addresses in case you would want to interact with us afterwards, or you have questions you want to direct through us to the speakers. Obviously, you can contact them directly also if you wish. So I'll start by just giving a little bit of motivation. You are here already, and therefore you must be interested in this. One of the most kind of influential reports that were written in this area is a set of smarter reports prepared by the GESI initiative, the Global E-Sustainability Initiative, now called the Global Enabling Sustainability Initiative. And it concluded that ICT has got emissions that are equivalent to about 1.9 or so of the total world emissions. And if we look at the total emissions, they are due to three main areas: end user devices, data centers, and networks. End user devices account for about 47% of the total emissions, and these are things like smartphone, tablets, PCs, printers, and others. Data centers, these may be the very big centralized data centers, or now increasingly distributed processing at the edge of the network, about 28%, the servers, the data transmission, the computing units, and so on. And then the networks, which account finally for about 24%, wireless and wired, enterprise, home, data transport, and so on. So in this webinar, we are going to hear about networks, but also about data centers, because we have seen, and you will see that software has meant that many, or softwarization has meant that many of these areas have just become joined up. And therefore, many times we actually use the processing within the network itself, and therefore the two are not totally separable as they used to be. The driver for growth in emissions and so on has always been traffic. And at the turn of the century, traffic in networks was growing at about 300% per year. People obviously expected it to grow even further. Instead, what happened is it diminished like this, and therefore we had the burst of the bubble around 2000. But still, traffic is growing in networks at about 30 to 40% per year. And in case you think about 2% of the world emissions is not significant, that is comparable to the global maritime industry or the global aviation industry. So it is quite significant. At 30 to 40% growth per year, it means that traffic doubles every 2 years, increases by 30x in 10 years, and by 1000x in 20 years. And what this means is that if we were to find ways whereby we can improve energy efficiency by a factor of 1000, then in 20 years, we will be able to consume the same amount of energy as today while accommodating 1000x more traffic. This is an example, and this and the previous one are courtesy of Bell Labs. This is an example of the traffic in North America, backbone network, the traffic in terabit per second versus the year. You can see the smallest by volume is wireless voice. The fastest growing is wireless data. The largest by volume is internet video, and then there is peer-to-peer. And those are the areas that we really need to address to be able to improve energy efficiency, and obviously all the processing and so on that goes with them. So there is a mix of services, and this is very important from an energy perspective. And also we have to remember that mobile is less efficient than fiber optics. So when we talk about 1000x improvement, usually that means that wireless or mobile has to achieve a much higher improvement in energy efficiency compared to the wired part of the network. I'll just say one or two words about the IEEE Sustainable ICT Initiative. This is a pan-IEEE society initiative whose goal is to really try to embed sustainability in the different activities within the Institute of Electrical and Electronic Engineers. So it tries to build a holistic approach to sustainability through ICT by incorporating green metrics throughout the IEEE technical domains. What it does is it tries to introduce, and it has introduced a number of standards. So we have got 9 already, dealing with sustainability and sustainable ICT. If you're interested, please get in touch. Conferences and events, publications, and education. So I mentioned 9 standards have been put in place since 2017. We have a Sustainable ICT Summit, and also the initiative helped introduce the IEEE transactions on green communications and networking, and there is a project ongoing to introduce a magazine in sustainability and ICT. Okay, so here is our lineup of speakers, very impressive, and we're very fortunate to have them here with us today. Marie is going to talk to us and share experience from HPE in France. And Louise is going to talk to us about her experiences in BT. Kiran from FutureWire. Maliki from University of Ottawa, and Fabrizio from University of Trento in Italy. So this is just the titles. Louise is going to start, and she will talk about sustainability and green networking, how important for mobile operators, and she will give an operator perspective. Then we have got two vendor perspectives. Marie is going to talk about how can vendors support a telco world in achieving sustainability. And Kiran is going to talk about green networking. Do we need to design a new IP for that? So start with an operator, then two vendor views, and then we have two university views looking at a little bit more into the future. Maliki is going to talk about machine learning and AI. Is it sustainability enabler or inhibitor? I have to also mention that Maliki has got a dual role. She is with Ericsson, but also with the University of Ottawa. And finally, Fabrizio is going to talk about how softwarization techniques can help build a sustainable telco cloud and any further challenges this is going to bring. So I welcome you again to this webinar, and I hope you enjoy the different talks. Remember, please, to add your questions in the Q&A part of the platform, and we will have that towards the end. So without further delay, I hand over to Louise to get us started with the first talk today.
So, hi, thank you for introduction. Let me just do the share business. And hopefully you can all see my slides.
Yes, we can, thank you.
Great, thank you. So context, BT is one of the world's leading communication service provider companies. We serve the needs of customers in the UK and more than 170 countries worldwide. We have fixed line services, broadband, mobile, TV products, networked IT services, and wholesale services. And as part of that, we provide critical national infrastructure for the UK. That includes 999 emergency services, but we also do things like we could connect sensors on dams that detect changes and so help to avoid catastrophic failure. And those types of services are never more in demand than when disasters occur. And those disasters can affect our infrastructure, they can wash away the roads and the cables buried beneath them, but they also affect people's homes, people's lives. And those disasters are becoming ever more commonplace as a result of climate change. And we've been aware of these potential problems for many years now, quite a long history of taking action, do things such as reducing our energy use through programs to close down old systems. We've been replacing heating and cooling infrastructure in our exchanges and offices. We've been working with our suppliers to help them reduce their carbon footprint. Our home routers were redesigned to fit through a letterbox to reduce the emissions associated with delivery, and they can be returned to us for refurbishment and reuse. We started migrating our fleet of around 30,000 vehicles, which is the second largest in the UK, to electric, having already installed several hundred EV chargers to enable that. And of course, we're on a zero carbon green electricity tariff. Although we do recognise that we still need to reduce our electricity use, as we are using electricity even on gloomy, still winter's day when there is little green electricity generation. Indeed, today, the electricity grid is undergoing huge changes to decarbonise the UK's electricity, whilst at the same time needing to scale up to support the electrification of transport and home heating. So reducing our electricity use can make it much easier for the UK electricity system to reach its net zero. And to sort of place that in context, I'm not talking about a minor perturbation. We use nearly 1% of the UK's electricity supply today. So we have ambitious targets to achieve net zero well ahead of the UK 2050 target. We're looking at 2030 for our own operations and a 2040 target for our supply chain and customer emissions. And we are confident that those targets are evidence-based and achievable. So, looking at some of the detail behind this. The left-hand chart just shows how our electricity use is broken down within the business. Mobile is a large share of the total electricity use despite its significantly lower traffic volume. Also note the large size of the section there labelled analog voice, which is the sort of old analog services, because I'm going to come back to that later. But it's not just our electricity use that matters. In terms of our carbon emissions, our Scope 3 emissions dominate. Scope 1 emissions are the emissions we produce directly from burning fossil fuel ourselves. So that's like petrol in the vans that we use to maintain the network. Scope 2 emissions are from the production of electricity that we then use. And Scope 3 emissions are the indirect emissions associated with our business, which is everything from the employee commute to the emissions from on-site caterers. These are actually incredibly difficult to really understand, in particular because of the depth and complexity of supply chains. And there is no limit to the number of pathways that contribute in some small way to the total supply chain emissions of a product. But we can estimate that our Scope 3 emissions are significantly larger than our Scope 1 and 2 emissions combined. And a more detailed analysis suggests that the two dominant factors are the emissions associated with making new equipment and the emissions associated with the operation of equipment in the customer premise. So as the UK migrates to green electricity, this latter will become less significant over time. So that leads me to the technical challenges we have to overcome, and I've grouped them into three main areas. Energy consumption, embodied carbon, and climate change adaptation. So first, the less electricity we use, as I said previously, the quicker the UK can get to its net zero. So to do that, we need to be able to migrate from legacy systems to turn them off. For example, if we wanted to close 2G systems today, we see that we have many systems have significant numbers of 2G devices, only 2G, that work perfectly well. Those sensor dams are sometimes a good example. And migration to 5G will be expensive and time-consuming for the customers with no actual benefit for them. Other applications may use features that are not available in later generations of mobile. So when designing new solutions, it would be really good to think about how they can be gradually closed down when their time comes, and to think about how corner case legacy support can be offered. We need to break the link between rising traffic and rising energy use. Fast traffic growth way outstrips the improvements in energy efficiency. And we need, as part of that, to be able to better adapt the whole system to the actual traffic load in a way that doesn't affect the operator's quality of service. The operators, mobile operators, are all compared on the service that they offer. And if we take the decisions to start powering down certain mobile masts and reducing the amount of bandwidth available at any one point, that will affect our rankings. So people are reluctant to sometimes do those things. Most of our environmental impact is in our supply chain. We need to reduce that, and we are working closely with suppliers to help them make the necessary changes. But things like having a technology that has a much longer lifespan would seriously help. But also we need to have data to better understand the supply chain. Looking at where components are made, having a traceable supply chain would enable us and our suppliers to make better choices. And then when things finally do reach end of life, also looking at how we remove legacy systems to reuse the precious components and materials within. I think we're quite often when we're designing new systems and services, very scant attention is paid to any kind of end-of-life management, and I think that really needs to change. The final area of concern is that a lot of this has been about preventing climate change, but climate change is already happening. So whatever we do, we need to be able to adapt, reconfiguring the networks easily in time of disasters, identifying what sites are still up, how operators can work together. I've included alternative energy sources here, as reliance on the electrical grid can be problematical in those times of crisis. And I've also included reducing not spot coverage. I mentioned earlier the energy costs of legacy analog voice. That, however, is the only service. In fact, it's the service with the greatest coverage in the UK, and it's the only service that can remain operational when the electricity is down in a wide area. as we can provide power from our emergency generators to the home phone down a copper line, and we can't provide power over the fibre or radio. What we need is the ability, we want to get rid of that legacy voice. It's using huge amounts of electricity. We can add all the traffic it's carrying to the strategic platforms without noticing. But we need the ability to cover any community at any time with basic voice services for emergency purposes, be that calling for an ambulance or just checking in with somebody who may be struggling. And when people are in disaster situations, those kinds of contacts become increasingly important. So mobile is the obvious choice for that, as it's low power. Handsets are relatively easy to keep operational, you know, whether it's charging from a power pack or from a car engine. So we need to sort out the nut spots to enable that. But these latter issues around adaptation are also what's led us to join the CREDO National Digital Twin Programme. Breaking that down, a digital twin is a digital representation of a physical asset or process that spans its life cycle, and it can update from real-time data. Users can then model and visualize system outcomes before they happen, which enables better informed decisions and ultimately saves us time and resources. And a national digital twin is envisioned as an ecosystem of connected digital twins. And the National Digital Programme is basically a collaboration agreement between 3 UK utility providers, ourselves, Anglia Water, and UK Power Networks, who provide electricity, as well as a number of academic and research institutes to work together on a climate resilience demonstrator. So when we think about a storm event, lots of flood and wind damage, mobile masts hit by lightning, electricity cables down, people needing emergency services and want to check in on their friends and family. How do we help the various organisations recover as quickly as possible from this situation? The premise is that by sharing information, giving us all a common description of the problem, we'll be able to better work together to prioritise resilience work. So making that specific, imagine a major storm has led to widespread flooding. The Highways and Environment Agency's knowledge indicates that the flood depth is quite shallow in some places, making it easy to reach certain assets, while others may be impossible to reach for repair for a long time. Using that information, the mobile providers could work together to then calculate alternative potential coverage plans, perhaps using all the mobile operators rather than each operator working individually. And we could also know that which of those mobile base stations currently have electricity or could be easily provided with electricity from the electricity company. And the electricity company would also know which masts we were particularly keen to get electricity supplied to back to quickly. So by working together with the shared information, we could quickly build up and bring back the communication networks for that area. We can also imagine using this sort of thing ahead of any problems. We could know which masts are at greatest risk of losing power for long periods and so provide alternative power sources there in advance. So by working together, we can build a more resilient set of infrastructure at a lower cost that helps us cope with the changing world that we now live in. The phase 1 climate resilience demonstrator was a rough and ready proof of principle involving just 3 infrastructure providers, a limited geographic region, focused just on flood. But we have shown it is possible and we're looking to expand this. So sustainability and green networking is vitally important for mobile operators. It is much more than just efficient networking, with challenges from the lowest level of silicon and materials to challenges that we can only overcome through human interaction, possibly mediated by regulation. But at any level, the best solutions are those that are going to be fully aware of the wider context in which they are being presented. To that end, thank you for listening to that context. Thank you.
Thank you. Thank you so much, Louise, for sharing those fascinating views, Scope 3 emissions and climate change. So an operator, I guess, has to deal with so many things. So we continue our webinar, and the next presentation is going to be given by Marie-Paule. And Marie, if you're able to share your screen. Okay. So over to you.
Thank you, Jaafar. I hope you can see my slides. So I'm from HP, as mentioned. and I will be talking about sustainability and the vendor point of view. I will be speaking actually on behalf of not just HP, but also on behalf of my Green G chair position. I have some trouble actually moving the slides for some reason. Oh, here it is. So Louise has talked a lot about, the impact of climate change. We all know that, from our individual position, but the impact is also huge on service providers and on everybody, even the vendors. And this is all the different occurrences that we see of droughts and fires and floods and so on. And so that's impacting the service availability, that's impacting the cost of operating the network. And as we know, it's just getting worse and worse. So how can we prevent that from getting worse? You're probably all aware of this intergovernmental report that came out in August last year, and a few additions that came more recently from IPCC. And this is clearly highlighting a few things that first have a major impact on the climate change, and second, things that we can do to adapt, as mentioned by Louise, and mitigate. And this major impact is due to the CO2 emissions that we put in the atmosphere, and that really change the whole balance that we have on our planet. There is a critical point associated to that. So what you see on this diagram is the different scenario that were described at this IPCC latest report. The one at the top, or the curve where we are currently if we don't do anything. So basically the temperature will increase by maybe 3, 4, 5 or more degrees Celsius. And just a few degrees can really make our life very difficult. So we clearly need to avoid that. And to be able to avoid that, we need to decrease dramatically our emissions, our CO2 emissions. And these are the curves towards the bottom. And there is an inflection point, which is 2025, which is being considered by the scientific community as being the maximum peak that we can get in terms of CO2 emission. After that, we need to clearly decrease and get to this net zero that has been highlighted by Paris Agreement and others by 2050. And to be able to achieve that, we need to start now, and we need to really do anything we can do to decrease these CO2 emissions. So Louise, has mentioned things that operators are already doing, moving to renewables and so on. Vendors also working in this direction. And the overall ICT community has to decrease not just the CO2 emission, actually, all the greenhouse gas emissions by 45% by 2030. And this is the output from the ITU specification, the L1470 that you see on this diagram, to really reduce the greenhouse gas emissions of the ICT to meet this 2050 net zero emissions. But actually, this is clearly the most critical point, but this is not the only point. We have, as an industry and as other industries, but talking about ICT, we have a broader impact on the environment, and all these things are tied with each other. So the climate change, the CO2 emissions impact biodiversity and everything else. So we need to have the holistic approach to the impact we have on the environment, and not just look into CO2 and GHG emission, but also look into the water usage. We need to look into materials, materials that we extract, materials that we use, that we dispose, look into the waste, and look into this whole supply chain and what is being called the circular economy. So from design to end of life. And this is what we are working on as part of this Next Generation Alliance. Green G working group that I'm sharing with a few of vice chair. And we issued a report to really emphasize, all the different aspects that we need to work on as an industry. And there's a number of metrics and KPIs that we need to look into to be able to improve on all these different topics. So on CO2, we need, of course, to target, the net zero, and then we need to have science-based targets on a regular basis, looking at how good, we are in reducing this CO2 and GHG emissions. Same thing for water. We need to look into the water consumptions. We need to reduce that. We need to avoid stress areas and so on. So there's a number of KPIs for the water. There's a number of KPIs for materials as well. We need to, of course, use more sustainable material, avoid these rare earth materials, which require to dig lots of land and so on to extract very few material. And we need to recycle. Of course, recycling is probably, one of the key elements. We need to be much more efficient in recycling equipment. We need to make a business model around recycled equipment, reuse, remarketing, and all these aspects of the supply chain. How is HP addressing all of that? So of course, we are aligned with the Paris Agreement. Of course, we are aligned with the net zero by 2050, and we have set intermediate target with science-based targets for 2025. We have already reached some of them. So we are moving to renewables as much as possible, 50% of the total electricity consumption. We are also looking into the supply chain and all the manufacturing related emissions. So not just, what we consume when we install the equipment, but the whole life cycle. We are looking into also the greenhouse gas emissions in operation, and we are looking to increase the efficiency of our portfolio, all our products, by 30% from 2016 baseline. So this is a big commitment. We are looking not just at single products, but at the whole life cycle and the whole operation of the company, scope 1, 2, and 3. And so we are also we have started to look into best practice and new methodologies for eco-design, for improving the supply chain, working with our partners, training our partners. We are, of course, looking into the end of life, the waste, the recycling, and working with customers also to also educate them on what they can do. We help them also to recycle. We help them also to improve their scope 3, as mentioned by Louise. One element that today is difficult for operators and for many people in the industry is to evaluate and to improve and to reduce the scope 3 emissions. And so as HP, as a vendor of HP hardware, we are providing carbon footprint details on our products. And we help also customers to evaluate their circular economy with a methodology to calculate actually their scope 3, and we also help them to collect equipment after end of life and recycle the equipment and use more recycled equipment. We are also working on data center. Data center is one of the big areas in the ICT, of course, with devices and also the network and the operation of the network. And we are helping data center infrastructure with studies and improvement of the cooling. The cooling is actually a big component of the energy consumption of a data center, between 30 and 55%. And by introducing what is called free cooling, air cooling from the outside, we are reducing significantly the energy consumption. We are also providing not just hardware, but we provide also software. And HP as a telecom organization that is working on 5G, and we provide 5G core network functions. And for that, we are also working on reducing the energy consumption. We are working on NWDAF and AI and machine learning, actually, to reduce the paging energy consumption. As you may know, when a device gets disconnected from the network has to page that device. And unless it knows where the device is located, then it's sending the paging to many base stations and RANs. And this is very energy consuming, up to 30% in MME. And this needs to be improved. And so we are working on tracking the location of the device and being able to predict a given location so that we can just page that area. And this is clearly a good way to optimize the energy consumption and reduce the impact of paging. We also have been working a lot on improving the architecture and the implementation of the core of the network. And so with 5G core, we worked on a cloud native 5G core with more and more efficiency improvements, thanks to metrics that we are collecting. So we are collecting many metrics on the load of the network functions, load of the slices, and power consumption metrics as well. And thanks to AI and ML analytics, we're able to provide a closed loop with service orchestration. And so we have different products for that, with our intelligent assurance for AI ML and service director for service and slice orchestration. With that, we can automatically reallocate resources, scale down, scale up, and so on, and automate that. We've done lots of work on automation and zero touch to really help service providers improve the efficiency of their network and the resource allocations. So with that, I hope I give you a brief overview of what HP can do. And of course, we are very involved with standardization, as I've mentioned, but many other standards besides the National Alliance. Thank you.
Thank you. Thank you so much for another very interesting and fascinating view, all the way from reducing carbon emissions to Scope 3 to looking at some of the technologies that can help achieve this. So we continue with our presentations, and hopefully we'll come to the questions later. And the next talk is going to be given by Karen. So over to you.
Hi, can you guys see my screen and hear me?
Yes, we can. Thank you.
Okay, so I'm Kiran. I work with FutureWay, and I'm going to give a perspective from an engineer who's been working on network technologies and protocols. And the question was, do we need new internet protocols to develop energy efficiency protocols? So I need to put a new IP in perspective first. So as you see that 2030 is a significant milestone in many ways. From energy perspective, many corporations are talking about switching to renewable sources. And that would also be a time when 5G becomes mature and we start talking about transitions to beyond 5G and 6G applications. Similarly, in the fixed networks, we were looking at new Network 2030 initiative, and our goal was to come up with some new technologies that complement 5G and beyond 5G. So what kind of limitations we will find with fixed networks in order to solve emerging applications? We came up with certain limitations, and how to solve or address those problems is the set of new technologies and protocols, and together that's called new IP. And whatever that solution comes out, that will have to be energy efficient. And when we were looking at the limitations and the new applications such as holographic type communications that requires a lot of bandwidth and low latency, tactile internet or industrial IoT, space terrestrial internet, all these applications are new in 2020 to 2030 era, and their requirements for network resources are very high and stringent. And we were weighing all these use cases with respect to the requirements, and energy came into picture. And we could not say that one application will require less, it has to be more energy efficient than the other. It was pretty much all over the board that you would want pretty much every application to be energy efficient. And my perspective about reducing the carbon footprint is that, okay, we talk about different kind of renewable energy sources. Green energy is when you are using renewable power sources. Then you get to sustainable energy where you're just using locally generated you're using local renewable resources, 2015. But the data rate continue to go up. Your consumption for data will continue to go. We will still have limits on how we can use those green or renewable energy resources. So what we need to do is how those resources are used, how we use our networks have to be energy efficient. And that is an ongoing process, continuous effort. Even if we have reached 2050 where we are carbon neutral, we will continue to be, we have to be energy efficient. And when you look into the networks, we know that networks are over provisioned. That is required because we want to be able to handle bursty traffic situations. The networks have to be ready to handle pretty much peak demands of the traffic on a given day or at a given time. But when the problem is the networks are always on pretty much all the way. We look at our phone devices or end devices, they are energy efficient. They have a way to turn themselves off. But that's not the case with the network routers and switches. They're always on. And as a result, what happens is that they're consuming a lot of energy. And these networks are made of not just routers, but there are links. Those links, the way they consume energy, they are not rate proportional either. And finally, the data that flows over through that link, the traffic, it has a specific packet format. And those headers are not energy efficient in themselves. In the sense, even if I have a small network where I want to exchange the data, the amount of header tags I'm incurring by using fixed size larger headers, it is pretty expensive. So right now, the current architecture and protocol do not have knobs which helps us conserve energy, whether it is a network side or the router side or the link and the packet format itself. And one example is the mobile backhaul. Although a lot of work is being done on energy efficiency on the radio side, the transport part of mobile network hasn't changed yet. And this is a very simple example how we use a packet format in a backhaul transport. We have routing header information and the service information all encapsulated in the header. And what we use is a stacking technique. So using this model, if I use a multi-hop scenario just to send 4 bytes of information, I incur heavy overheads. And this is not really an energy efficient solution. There might be cases where I don't need a fixed header format to insert my service label or the customer label. And these type of stacking can be made a lot more flexible and efficient to the energy. There is also an inefficiency in the link utilization. I came to know that 10 years ago, there was a lot of work done on energy efficiency Ethernet. But the problem with these solutions is that with a low latency network like industrial IoT, which is going to be one of the major use cases in 5G, you cannot turn the link down and without losing any data. So we need to come up with much better solutions, something like adaptive link rate, where you say, okay, I'm going to set my link down to say 10 MB, which will reduce, which will not use as much energy, and gradually as my traffic increase, I increase the link rate so that it is roughly rate proportional. But the problem is these techniques are still not in use. The auto negotiation part, or how do you change your link rate, cannot be done efficiently now for the new applications. So these are some of the problems that we need to handle from the design of the link protocols and the routers. And as I said, that even the packet sizes themselves are inefficient. If you have large headers associated with smaller payloads, they consume a lot of energy. One option could be if I have a smaller network, let's say if I have just enough number of devices that can be covered with 16-bit. For example, if I have a network of 64K devices, I only need 16-bit of address space for that. And by doing that, I reduce the energy and the amount of information I'm sending over those links. And as this rate goes up, the gap also increases. So this is what new IP is about. The whole idea is to transition a fixed header format where we are stacking addresses and services in the header along with the payload, and make it more modular and programmable. What that means is that now I have a flexible way of representing my address. Your address spaces could be from, based on your use cases, they could be of different sizes, and you could use shorter addresses, or you continue to use V4, V6 for the legacy network setup. And you use contract to express your service guarantees, those applications that I talked about early on, that we need holographic type communications, or we need low latency textile internet services. So those are also important along with energy efficiency. Then there must be some requirements where you could explicitly express that, hey, I would prefer to take energy efficient path, and if that affects my latency, I don't mind. So those type of service requests can be expressed through contracts. And then payload itself can be disaggregated in the sense that consider a video application. And within a video application, there are certain parts of the frame that are more significant than the other parts. In that case, you could give a differential treatment and only drop part of the video frame that is not interesting to you. And why would we want to do that? Because when you have a large package size, the cost and energy spent in retransmitting that packet is much larger than just tolerating a lower quality of service. So these are the three different directions we can look at from the new IP perspective. So I don't want to go into a lot of details of other telemetry and criteria. I just wanted to introduce how new IP can help green networking. We know that traditional protocols were designed initially to meet the requirements of hardware of that time. But over time, we have started stacking customer information, service information, and path-specific information as stacks. So now my header stack is pretty bloated. We need to find a way to conserve energy in those in expressing those requirements. So in that sense, new IP promotes programmability. We only want to consume what we need, because there is we don't really want to compromise on the quality of services for the applications. For example, it will be regressive if my network cannot support tactile networking, which is important for applications like telesurgery or any remote operations on the factory. We want to support the KPIs for the emerging application, and that's where contracts come into picture. We want to make a topology which is energy efficient, a topology which is running in a low power mode, and it will have altogether a different quality of service requirements. The forwarding in packet processing can also be made more conservative, in the sense we can come up with router designs where TCAM perform lookups on shorter addresses, and that's how making them more energy efficient. And then the qualitative payload I talked about is how we can use payload to reduce the quality of service, but still save on energy for certain use cases. So new IP is a balance of new services and energy. It provides a perfect tool how you can express that balance and use the hardware accordingly. And finally, I think, why would we want to do it? Because green networking is not about the cost factor, it is a global impact. So we have to make all the innovations necessary, be it in hardware, software, or protocol. And that's pretty much what I have, and some of the research work which gave me inputs for these ideas. Thank you.
Excellent. Thank you so much. Very interesting and very insightful on how protocols can be adapted and changed to improve energy efficiency and reduce power consumption. Very interesting directions. So we continue with our presentations, exposing other areas. And the next talk is going to be given by Miliki, focusing on machine learning and AI. Please, when you're ready. Thank you.
Thank you very much, Jaafar, for this, for organizing this nice event, first of all, and for the nice introductions at the beginning. So my name is Marie-Paule Kantarci. I'm a Canada researcher in AI-enabled wireless networks and an associate professor at the University of Ottawa, and also chief cloud and AI/ML data scientist at Ericsson. Today, I will talk about our activities at the university. So I will be wearing my professor hat. And I will look at the AI, ML, and sustainability problem from two perspectives. So can we improve our sustainability by using AI, ML? And are we hampering sustainability by using AI, ML? So let's get to the bottom of the problem. Before I introduced a couple of the works that we did in my lab with my students at NetCore, in our lab NetCore, I want to give a brief overview of what are the activities that we are doing. So we work on energy efficiency, but aside from that, we do network optimization. So we do radio resource network optimization using AI and machine learning, and we mostly focus on reinforcement learning and deep reinforcement learning. This includes scheduling, beam management, and other aspects that impact the network performance jointly. We have developed a couple of schemes, and we have several patents in the area. And today I will focus only on two of the works that we did, and I will shift the focus from 5G towards a little bit to ORAN. Although the topic of this webinar is beyond 5G, I see ORAN as a complementary alliance and complementary standardization body that's promoting for multi-vendorness, where we can see different advancements than 3GPP. So we all know that 5G, beyond 5G and 6G is promoting already a lot of innovations in the area of AI. We see that AI will be very fundamental to this. And we also see that AI is very actively promoted in ORAN as well. So for those of you who are not very familiar with ORAN, ORAN is the short version for, or an acronym for, Open Radio Access Networks. I specifically use a dash in between because that refers to the ORAN Alliance, which covers operators, vendors, and lots of other players like system integrators. And the vision of ORAN is virtualizing, disaggregating, and promoting multi-vendorness. In our work that we presented in IEEE ICC in 2021, what we looked from the perspective, from the lens of ORAN, was more to disaggregation. So we know that disaggregation comes with the functional splits. Where do we do the lower layer functional splitting? Where do we do the higher layer functional splitting? And as a result, which functions, which network functions are handled by RUs, which network functions are handled at the DUs, which network functions are handled at the CUs. This is a very hot topic in the academia, having dynamic function splitting. So depending on different criteria, this can be managed. In this particular paper, we took the energy efficiency perspective, and more specifically, we looked at the availability of solar power. So depending on the abundance of the solar power, our decisions were whether to host some of the services as at the DU or at the CU. CU is the central unit. So it will have a larger deployment, a larger physical presence, so more opportunities for deploying more solar panels if we are using the solar energy. DU is more distributed. And we used, in this work, we used reinforcement learning, which is an interactive learning technique, interactive machine learning technique. So in reinforcement learning, agents interact with the environment. Once they are in a certain state, an action is initiated, the action impacts the environment, the state of the environment changes, and in addition to the change in the state, the environment generates a reward, whether the action was good or based on the action was good or bad. If the action was bad, this turns out to be a penalty. And this feedback is continuously fed to the agents to improve the future actions. And what we saw was we looked at 4 cities around the world. We looked at solar radiations in Stockholm, Cairo, Jakarta, and Istanbul. And we saw that our reinforcement learning-based scheme was able to outperform a distributed and centralized RAN scenario. So distributed means all the functional split all the functions are taken care of at the DU. CRAN for us in this work means all the functions about RU, about the lower layer physical split, is handled by the CU. So when comparing this, we saw that if we have an adaptability, if we can move the workloads of network functions from DU to CU based on solar radiation, we could actually improve our operational expenses. So this was the side of the network operations from an operator perspective. In energy efficiency, we also have a perspective from the user side, from the UE side, because we are constantly becoming more and more dependent on our devices, smart devices. Their batteries drain faster. And also this comes with the technological advances, the functionalities embedded, both related with the power consumption of modems and also the applications we run on the phones, on our smartphones impact this. So with this, energy consumption of UEs becomes a problem. And one of the technologies that we need to take care of, or we need to monitor the energy efficiency, is carrier aggregation. Carrier aggregation is a technology from LTE. We had it in LTE, but now with 5G, we are able to do this over multiple bands, including millimeter wave bands. What happens with carrier aggregation is component carriers are bundled up together to give more throughput to the users who need throughput. But this sounds very nice. But when the UEs receive information, receive data, traffic from multiple channels, they have to monitor all of these channels. And monitoring channels incurs some energy overhead. So they spend energy, they drain their batteries faster. So in this work that we presented in GlobeCom 2021 last December, we came up with an idea, and we said, let's try deep Q learning, which is a type of reinforcement learning that uses a neural network to drive the reinforcement learning agent. We said maybe we can dynamically tune the number of active component carriers such that we don't hamper the throughput, but at the same time, we use less component carriers. Hence, the UEs monitor less control channels and consume less energy. So we showed that by using our technique, we could achieve a similar throughput to the case when we activate all the component carriers. So imagine you're activating 3 or 5 component carriers with a regular scheme, like when you do the all component carrier scheme. And then imagine with deep Q learning, this is dynamic. Sometimes whenever the traffic need comes, you have 2 component channels, component carriers. Whenever there's high traffic, you have 3 component carriers or 5. So by doing this, and also latency could be impacted, we also showed that latency impact of this dynamic scheme was minor. So by doing this, we were able to save from UE energy. So as you can see, we have some examples where AI can be helpful to save power in terms of the network operations from the network operator perspective and also from the user perspective. But now, when it comes to when we come to the second question, whether AI can be a nuisance, I would say, to increase the energy consumption, the answer is yes, it could be. But we see that there is a trend in hardware and also utilization of AI that in the future, we can see this energy consumption to reach to a plateau and shrink. But before I get to that point, the things that we need to do to come to that point, I will talk about a paper that was presented in 2021, and it's a quite recent one, on the compute and energy consumption needs of deep learning. And this deep learning evaluated in that academic work is not telecom AI workloads. This is NLP and vision. So they took the well-known NLP data sets, computer vision data sets, and they compared several deep neural network algorithms and look at how many gigaflops they needed for computation, which can be translated into energy efficiency. Now, an interesting observation from this plot is that the architecture of DNN is quite important in computational capacity that the algorithm, that the AI model consumes. So instead of using complex, or I would say less sparse DNNs, if we go with sparse deep neural networks, which has less connections between the layers and still learning, given that learning performance is not hampered, we can actually consume less energy. Another thing that we observe in this picture, in this figure, is that year by year, the load has been increasing. Now, this is understandable because AI usage is increasing, data sets are the volume of data sets are increasing, the complexity of the models are increasing. But here there's an opportunity. With the model selection, we can probably take control of this. Now, another opportunity comes from a much more recent work from Google and University of Berkeley, that's by using 4 M's, that's their terminology, model, machine, mechanization, and map optimization, it is possible to reduce, at least to have the AI workloads energy consumption or carbon footprint to reach to a plateau and then shrink. So what are these 4 M's? The first M I already mentioned, it is the model. Selecting an efficient machine learning model can reduce the computational complexity significantly to the degree of 3 to 10 times. Then machines. Using processors or systems that are optimized for ML training is important. So if you run ML workloads on general purpose hardware, the performance, the energy efficiency performance might be poorer in comparison to optimized processors. Then mechanization, using cloud to use, because those servers, and this is related with the machine, because servers on the cloud, public clouds, are expected to be more optimized than the general hardware that you can find at a regular place like your own PC or maybe other on-premise computing infrastructure. Then the fourth one is map optimization. if there's a cloud provider that uses renewable energy and can shift the workloads depending on where the renewable energy is, then there is an opportunity to make use of this. And this is almost similar to, or very close to, what we motivated in our Oran paper. By choosing locations where renewable energy is available, we can actually reduce the energy impact of AI/ML. Now, these are the things that that have been evaluated both in my group and outside my group. And then an important question emerges about running AI at the edge and for network optimization. These are the things that we haven't evaluated much. We know that there is a certain footprint. It's not zero footprint to have AI models optimizing the network, but how can we optimize them? How can we use this 4 M's to improve efficiency? I would say is open to debate. And I will end my speech here, and I hope to have engaging discussions at the very end. Thank you very much.
Thank you so much, Mel. It's very fascinating listening to what machine learning and reinforcement learning and so on can do, but also how to reduce their own power consumption. So it's really very different perspective. So we move on to our last but definitely not least presentation, and a very interesting topic in this context given by Fabrizio, and looking at softwarization techniques in networks and energy efficiency. So over to you, Fabrizio.
Thank you very much, Jaafar, and thank you and Tarik for this event organization. I think it's very interesting and I'm learning a lot. Please let me know if you will not hear me properly, because in case I can switch off the camera, but I prefer if people can see me.
So looks good, thank you.
Okay, great. So first of all, I wanted just to give the picture about the situation as I see it. In this sense, there is a sort of interesting debate already in 5G that probably will carry on in 6G too, about let's say 2 tendencies. Because on one side, people say that 5G is more efficient than 4G because the energy consumption per unit of data is less. But on the other side, there is this graph that you see here in this slide that predicts that 5G will consume more power. Roughly, the idea is that globally we can have an increase that will bring us to roughly double, let's say, the energy consumption. So, first of all, the thing is to understand why on one side we are saving power and on the other side it seems that we are consuming more. And that is related to the fact that while we have more efficient devices that can really allocate less power for delivering the data, on the other side, we are making the system much more complex, and also we are making the devices more complex. So to some extent, we are experiencing a situation where we know quite well that, and there is let's say quite a unanimous opinion from Nokia, Telefonica, Ericsson, that 5G technology is up to 90% more efficient than 4G in terms of energy consumption per unit of traffic. And also the other good news is that the use of 5G will probably decrease the energy consumption of different industries like energy, transportation, manufacturing, by a very relevant amount in the next 10 years. And typically the estimate is around 1% globally in all these energy, in transportation, in manufacturing. So for sure, the development of 5G and then 6G will bring a lot of benefits overall for saving power. However, the problem is that 5G and of course also 6G will tend to have, for example, smaller cells, higher density of deployments, and this will increase the overall energy consumption. That is something that speaking with companies is worrying, and probably is also making the development of 5G itself and its deployment leaders, let's say, not as effective as it could be. So there are companies that are delaying the latest versions of 5G implementation because they fear an increase in their investments for the overall network maintenance. The reason, as I was mentioning before, is that today we have very powerful technologies like massive MIMO, edge computing, a lot of cells that will be required at different levels for providing high throughput and low latency. But also what I will focus here is the flexibility, because even flexibility comes with a price. In 5G, and most likely this will be even more true in 6G, we expect softwarization to become one of the main technologies that will be deployed. Since we want to achieve network slicing, we want to fully exploit the possibility to reconfigure the network in runtime, and also to be capable of offering personalized services to different vertical companies and vertical applications as well as consumers. So in this case, virtualization comes handy because it increases the flexibility, but also about AI. Also virtualization and softwarization are technologies that come with a price because they bring benefits, but also they might bring, let's say, issues to be solved. So if you consider roughly in the literature, today there is a quite good consensus on the fact that virtualization is a necessary technology in modern networks, because modern networks have very diverse workloads. So one of the benefits of virtualization is that we can better manage and consolidate workloads. Here I'm referring mostly to the slicing as the application, but also virtualization brings high flexibility, as Melike before was presenting. Is only through softwarization that we can achieve open run or very advanced resource allocation strategies. And to some extent, virtualization might also be used for sure to adapt the configuration of the network, for example, to the energy availability, because we might move or migrate some functionalities in order to improve the way we allocate resources to our network infrastructure. However, while virtualization brings these several advantages, it comes also with some limitations. One is that we increase the complexity of the overall system, and as a consequence, potentially we also increase power consumption, which seems to be in contradiction with the previous sentence, but we have to consider the fact that virtualization requires different kind of hardware, even though maybe a general purpose, but it requires a distribution of the hardware within the network that is different from the traditional way this happened. On the other thing is the devices that we are going to use for the physical infrastructure, that are those that really consume the power, are highly heterogeneous. So it is difficult to have a clear estimate about how the energy consumption varies, for example, with the traffic load or with different configurations. And this, of course, makes it more difficult to optimize the system power-wise. Another important thing that also partially came out already from the previous presentation is that to have effective virtualization and to use virtualization for energy saving, we need a lot of information, because we need to have a precise context awareness, and this might include also, as a consequence, the deployment of massive AI and machine learning technologies to be capable of handling the amount of data that is required to take a fruitful decision. So I would like just to close with 2-3 slides that represent some of the issues, and then I'll leave it open for the discussion. One thing is there are not so many words at the end about which is the price of virtualization. So how many watts, for example, we consume for a Docker container, or does the energy consumption changes if I change from Docker to, for example, Linux containers, or whether I use a container of a virtual machine with KVM or XAMPP. Here I just took an example, not much to show you the absolute value, because of course it will vary also from your hardware architecture, but here it is shown the fact that, for example, it seems that in the cases where they did this measurement, Docker containers seems to be more green, because for the same functionality they save power, they consume less. However, in another work they studied the aggregate power consumption of the hardware, exactly, because it's only hardware actually that is consuming really power, but with different levels of load. And in this case, Docker is still the last column that you see in the right part. You can see that if we increase the resource utilization, so if we load a virtualized machine a lot, what happens is that at the end, almost all virtualization technologies reach a boundary, because in saturation state at the end, there is not much difference from because probably the reaches a saturation in its consumption and also in the performance. So if we combine the previous slide with this one, this means that in some cases, for example, for low load, maybe Docker's containers can be better as virtualization technique. But if we have higher load, maybe a virtual machine might be enough, or maybe another solution might come more handy, because they are done for different things. Containers typically are for lightweight virtualization. Virtual machines are more for maybe probably heavy duty jobs. So one issue that we have in the literature today is also to have a clear characterization that of course is difficult because it depends on the hardware as well as on the software components about how energy consumption varies depending on how we configure the system, which configuration we select, and so on. So this for sure will call for some autonomous or machine learning driven optimization that should be done for sure runtime, because traffic is varying, requests are varying, applications and the setup of the network is continuously being modified. And my final message to you is summarized in this slide. So my opinion is that today we are, if you look at this diagram about the total cost of ownership, the one on the center of the slide, today we are somewhere in a situation where we are increasing the transformation of mobile networks, and at the same time we are increasing also the total cost of ownership, because at the moment what we are implementing is making the system more complex, because we are trading off somehow flexibility with the cost saving and as a consequence energy saving. However, here is the diagram that was originally from Nokia. However, there is a turning point both in the cost and most likely in the energy consumption, that where probably 6G will be headed, which is that once we will reach a complete technology implementation of virtualization and softwarization, then we will need to introduce automation. And it is when we will introduce network automation that most likely we will see really, for maybe beyond 5G or 6G networks, to become completely, let's say, profitable and green, because it is through automation, which also involves integration of AI in the network, that we can potentially decrease the total cost of ownership, because we will have a way to trade off the complexity that we introduce with a more efficient utilization of our resources. So With this, I would like to close my intervention to remain in the time, and I'm available for more questions about this. So let's say that I'm optimistic for the future. There is a lot of work to do, very fascinating, and we saw it also from the previous presentations. However, I think that the trend is at the end positive. Thank you.
Thank you. Thank you so much, Fabrizio, for this quite interesting number of points about consolidation, the flexibility you get out of that, but then the need for automation. And it seems so many of the things are very interlinked. Tarik is going to be with us soon to start the questions and answer session. Tarik, over to you. I know we have much limited time, so we have to be kind of selective on the sort of questions we want to.
Yes, indeed. Well, Jaafar, thank you so much for moderating the webinar. You have been doing a tremendously great job. Thank you so much. Thank you all the panelists for your very insightful presentations. I have actually learned a lot, and I think the audience share the same view. I've seen that there are lots of questions that have been asked actually on the using the question and answer tool. Some of them have been already answered, or by having the panelists type in their answers. Thank you. There are still some questions which are actually still unanswered. So we'll read through them. I think the panelists can do the same thing. So the first question that I would like to take is to Louise. Can you talk much about the ways that mobile technology can help reduce carbon emissions? Louise.
Yes. I always find this one an interesting one, actually. How can technologies reduce emissions? We've identified a whole range of applications where mobile technologies can be useful, whether it's in smart cities, directing traffic to free car parking spaces, in agriculture, having sort of IoT-based systems that can communicate and work out just precisely what level of fertilizer to add to a particular field. Basic video conferencing, here we all are sitting around, 2-3 years ago, we'd have been jetting off 1 or 2 times a year to a conference to catch up these kind of events. Now we just sit and do them all online. And so there's clearly loads of opportunities and ways in which we can use technology to help us reduce carbon footprint. My concern is that despite all these wonderful things, all these wonderful ways in which we can use technology to reduce carbon footprint, as a nation and as a world, our carbon footprint is always increasing. And a lot of that seems to be with how we use the technologies and the choices that we make. So if it's easier to park in the town centre, that means some people will go out more often to park in the town centre because it's easier, it's less stressful. So in fact, rather than saving energy for not queuing and driving around the town finding a car parking space, now people are going more often. Video conferencing, there were businesses who used to work just purely locally. Once they started using more communication technologies, they expanded the geographic reach of their business. So while they didn't need to go and visit those customers every week, they would still go and make face-to-face contact with those customers once every 6 months or so. And the net impact of that was that the advantages that they gained from these new applications meant they could do more of something, which essentially then negated the savings that they managed to gain from the application in the first place. And it's almost, we talk about this correlation between energy use goes up, because even though things get more efficient, the traffic is growing all the time. And I think it's the same with all these carbon abating technologies. Although we're becoming more efficient, we're doing so much more of everything that the net effect is an increase in the emissions. So I always find that one quite an uncomfortable thing to think about, because we want to break that link between energy consumption and traffic. We also want to break the link between, how we behave and how we use applications and the carbon emissions that come from them. I don't think we've broken that link. I think we're just becoming more efficient.
Thank you so much, Louise. Thank you so much. Actually, this will take me to another question to Marie. I mean, there is a question from How, who says that actually there are many operators that are interested in deploying edge cloud. Yes, there are lots of services that are actually in need of service to be closer to the end users. And as you know, any edge cloud will be consisting of different servers. This service to produce them means that you know, certain energy was spent. So what kind of advice can you give to those new emerging operators that are actually willing to deploy edge cloud? What kind of advice to give them so they will select the right equipment to build an edge cloud that didn't have, you know, very high, let's say, carbon footprint? I mean, during the runtime as well as when it was, you know, being manufactured itself.
Yeah, that's a good point. Yeah, clearly there is, you know, this big trend towards edge computing and this debate of, you know, concentration, you know, in big data center versus distribution with edge. I mean, as you know, HP, we are doing lots of work on the edge, and we worked on providing hardware which is highly efficient, both in terms of the flow footprint, because again, you know, I'm back to my environmental footprint. It's not just CO2 and energy and power consumption. We need to look at the big picture, including the land, you know, that we occupy. And so with the HP Edge line, this is the focus. We are working on hardware which is very optimized in terms of the flow space occupation, and then in terms of the energy consumption. Then I liked very much, you know, the presentation from I need to spell her name, Melik, about the AI. Sorry, I misspelled your name maybe. And the workload of the AI and the energy consumption. We are doing lots of work to help customers to select the best acceleration cards, you know, to put on the hardware, the edge, to really also optimize the ratio between, you know, efficiency, energy efficiency and performance, and this is another big area. And then I would also highlight that, you know, what Fabrizio emphasized, but that was also my point. It's very important to have, you know, proper metrics and to really allocate, turn on, off, you know, resources and balance the loads efficiently. Just based, you know, on the traffic predictions, thanks to AI and so on. And to have that automated, very important to have the automation and the zero touch, even more, you know, with the edge and you know, duplication of resources. The more resources you have, the more you need to optimize them.
Thank you, Marie. Thank you. Actually, there has been a lot of questions that were actually asked to Kieran, and thank you, Kieran, for being very active in answering them, mainly that we don't have much time, you know, till the end of the webinar. But there was a question to Fabrizio, which I really liked. I don't know, now it doesn't appear, but if I recall, it was the question about the 5G core that is supposed to be, you know, distributed, you know, run on the cloud. One that consume more energy than what we have nowadays as centralized 4G core. And there has been an agreement. I think that the run consumes more energy than the core, but probably I think when it becomes in the context of the 5G core being distributed, probably the core will be consuming more energy than the radio access network. What do you think?
Yes, thank you for these questions. By the way, it's very interesting. In fact, I answered in text, but I will repeat for everyone.
Yes, please do.
What I wrote, yes, what I wrote, yes, what I wrote is that I cannot say that in every case 5G core will be more energy efficient than 4G core. What I mean is that 5G core, with the flexibility that is enabled by softwarization, provides some scenarios and the adaptability that can allow us to save power or at least to manage power in a more efficient way. What I mean is that, for example, a lot of providers know that the traffic that comes in the network varies over time, and it is quite predictable during the day. There are peak hours and, let's say, the night where maybe there is less traffic. And just for this, in 4G you cannot do much because the core is practically fixed, so you can use traffic engineering, but you don't have so much flexibility. While in the 5G you have the capability, for example, to migrate everything. Even you have virtual routers, a lot of advanced components that can allow you to have higher degrees of flexibility in improving this energy consumption. And another thing that I was thinking was that, for example, let's take private networks. Private networks are one technology that 5G will become probably popular for, and most likely also 6G will continue. And in this case, in 5G private networks, you can practically have most of the core in the cloud directly. So you can manage it in a data center and use a very, let's say, very few physical components. So I think in principle, there is possibility to reduce the power consumption, and overall they will happen. But I cannot tell that it will happen all the time, because it will depend mostly on the deployment and also again on the automation. Right? I have the impression that automation will be one of the key aspects also in 6G, because as the network becomes so complex, to have a way wise or performance wise will require a machine to think rather than a man, let's say. So that is my answer, but I'm available also offline to maybe discuss more.
Yeah, I mean, definitely, Fabrizio, this question, I think it's worthwhile research, and yeah. So I'm probably we can we're almost like over time, but I would like to ask Kiran and Meleki just to share with the audience thoughts on what kind of topics researchers have to focus on, in this area of green networking. Maybe Kiran, you can start, and then Meleki, please.
Yes, so I am a protocol person, so I look at routers, links, and the packet formats. So I think there is a lot of potential, as I already alluded in my presentation, that going forward, coming up with a more modular design of routing protocols, not the routing protocol, sorry, the routers themselves, so that the resources on the routers, such as TCAM, lookup tables, and the links, how they are powered on or how they change their speed, those things can be modified. So that will be quite an interesting thing. Second thing is, we do need diversity of path in networks. We need multiple ways in order to build resiliency in the network, something like for the critical infrastructure. So how do we use AI ML models to come up with paths with different energy efficiency to really have your traffic flowing, but at the same time in an energy efficient manner? That is another research direction. And I think link utilization, that was the question answered on the chat. So that's quite important for me as well. Yeah, so those are my thoughts.
Indeed, that was a very good question, I think, from Somaya about the link failure, and yeah, that was a very good answer, and it was actually answered on chat. So I invite the audience to check it out. Yeah, Meleki, please.
Thanks, Tarik. Actually, there were quite a number of questions in the chat that I tried to answer. And one of them actually reminded me that one of the things I did not mention when I was presenting, and I believe this is an important thing that needs to be discussed, when we talk about energy efficiency of AI workloads, we usually tend to think about training cost. But there is also cost to inference. So I think earlier you had asked what kind of aspects could be researched. I think this is one of the fundamental topics. because with some machine learning techniques, inference might be also as maybe not as costly, but it can have a non-negligible cost in terms of energy efficiency. So that would be an important direction to address, in my opinion.
Okay, thank you so much, Meleki. Thank you everybody for these very insightful and very interesting discussion that we have been having on green networking. Jaafar, it has been a pleasure moderating this session with you. The final word for you before we close.
Thank you so much, Tarik, and thank you everybody for the very insightful presentations, all the ideas that you shared with us, all the challenges that you have put forward. So I hope the community is going to embrace many of those, and I'm sure they're going to. And finally, I just want to say thank you so much to Tarik for coming up and putting forward this and making it now working together a reality. I think this is just a start, and hopefully we can do more of these events in the future, because the challenge is for our planet, and it's never going to be totally done. So hopefully we can continue. So finally, just thank you so much, everyone, and hopefully we're going to share the presentations and also the videos online. Thank you.
Yes, we will be doing that. And actually for that purpose, probably, may I invite all the panelists to turn on their cameras? Maybe we can take a screenshot. Okay, thank you so much. I think it has been a great webinar, really. It was very interesting to hear from all of you. And really, thank you, Kiran and Meleki. You know, I know it's too early for you guys. For us, it has, you know, the Easter has started. I think we are in the mood of the Easter now. And Louise, Marie, Fabricio, thank you so much. Jaafar, it has been a pleasure.